Welcome to the fourth unit of the Working with Regular Expressions for Text Processing course. So far, you've explored what regular expressions are, understood their applications, and learned how to implement them in Make. You've even tackled some complex use cases. In this unit, we'll delve into the Match Pattern Advanced module. This module builds on the basics you already know, allowing you to specify a regex pattern, input text and flags, while providing enhanced control and flexibility. Through this module, you'll gain insights into new functionalities and see how they can be applied in practical scenarios. Let's dive in and discover how this advanced tool can elevate your text processing skills. Welcome to the Match Pattern Advanced module. This tool might seem similar at first glance to the standard match pattern module you're already familiar with. You can still specify a regular expression, define your input text, and set flags. However, the real power of the advanced module lies in its ability to map items directly within the regex pattern. This mapping feature opens up new possibilities for precision and control, enabling a deeper level of customization in your text processing tasks. Whether you're handling complex data extraction or fine-tuning search parameters, this advanced functionality provides the flexibility you need to tailor the matching process to your specific requirements. Let's dive into how you can apply the match pattern modules effectively. The standard match pattern offers reliable capabilities, but the advanced variant takes things a step further. It allows you to map items directly within a regex pattern, giving you enhanced flexibility. Imagine scenarios where your data requires more nuanced filtering. The advanced module allows for complex pattern recognition, essential in diverse real-life situations. You'll encounter examples showcasing the necessity of this module and get hands-on experience in configuring these patterns. Get ready to explore how these tools can elevate your data processing skills. Imagine you're an explorer, much like Erica, navigating the world of data validation with regular expressions. Regular expressions, or regex for short, are powerful tools used to describe search patterns, particularly useful in validating data like postal codes. Erica faces a challenge. She needs to ensure the postal codes from various countries are correct in her spreadsheet. Each country has its own unique postal code format, necessitating different regex patterns. This is where the Match Pattern Advanced module comes into play, offering the flexibility to map these diverse patterns efficiently. By leveraging this advanced module, Erica can apply a distinct regex pattern tailored to each country's postal code format, enabling her to verify all the codes in one cohesive step. This method streamlines the data validation process, saving time and reducing potential errors. As you delve into these examples, consider how these tools can be applied to your data tasks, blending precision and efficiency in handling complex data structures. In Erica's travel agency, she provides a driver service and needs to manage driver information efficiently. However, her database lacks car registration numbers, which are crucial for identifying vehicles. These numbers are stored in documents with messy and inconsistent formatting, making manual extraction not just tedious but impractical. This is where the Match Pattern Advanced module becomes invaluable. By creating a specialized regular expression, Erica can identify both fixed and variable parts of the registration numbers. The fixed part might include standard prefixes or format markers, while the variable part captures the unique sequences found in each registration. By implementing this solution, Erica can automate the extraction process, ensuring that all car registration numbers are accurately identified and stored in her database. This not only streamlines her operations, but also reduces errors, enhancing overall efficiency in her service. The Switch module is a powerful tool that allows you to generate different outputs based on specific conditions in your data. By matching input data against a list of values, you can dynamically control the output. Whether you're working with simple text or more complex patterns using regular expressions, The switch module evaluates the input for a match. For simple text, it seeks an exact match, while with rejects, it looks for a pattern within the input. This flexibility ensures you can tailor the responses precisely. For example, in one scenario, matching a pattern like 123 inches might output a heart symbol, while a different pattern such as 456 inches might produce a different symbol. If none of the specified patterns match, a default output is provided. This feature enhances your ability to handle diverse data inputs effectively, ensuring the right response every time. Let's explore how the switch module operates to handle different outputs based on varying conditions. Picture this. You have an input, and you're trying to see if it matches predefined patterns. If the input matches case 1, like checking if 123 is equal to 123, the module outputs a specific symbol, a red heart. This immediate match stops further checking right there, making the process efficient. If the input doesn't match case 1, it then moves to case 2. Similarly, if 456 matched the input, it would output a purple heart. However, if none of the specified cases match, the module defaults to an else condition, producing a different symbol entirely. This functionality is flexible because it allows you to use either simple text or more complex patterns, like rejects, for determining matches. Ultimately, what you get is always a string, providing consistent output formatting no matter the conditions. Let's dive into how the switch module operates. Imagine it as a sorting process. When an input, like a number or text, is received, the module compares it against predefined patterns. These patterns can be simple text or complex expressions known as rejects. If the input matches a pattern, a specific output is triggered. Consider this. If the input is 456 and matches a pattern set for case 2, the output will be a purple heart. This is because the switch module found a match at this stage and concluded its job here without checking further. If no exact match is found in cases 1 or 2, the module uses a default response, which we refer to as else. This ensures that there's always an output meeting the conditions you've programmed. By using the switch module effectively, you can streamline processes and automate complex workflows based on precise criteria. This allows for enhanced efficiency and accuracy in scenarios where diverse outcomes are necessary. Welcome to an overview of how the switch module functions. This module is a valuable tool that lets you generate different outputs depending on specific conditions. Think of it like a decision maker that selects outputs based on varying inputs. Let's break down how it works. The module evaluates the input data to see if it matches a list of predetermined values. Depending on the match, it delivers a unique output, which is always a string of characters. The patterns you set can be simple text or more complex rejects patterns. For simple text, the switch looks for an exact match. However, with rejects, it searches for a match that fits the specified rejects pattern in the input. Imagine you have two scenarios. Case 1 matches the pattern 123, resulting in a heart symbol as the output. Case 2 matches 456, giving a different symbol, a heart. If the input doesn't match any patterns, a default or else output is used. Understanding these basic functionalities of the switch module will soon be important in our upcoming use case on validating postal codes. Stay tuned to see how this can help solve real-world challenges. As you see here, Erica the Explorer has a spreadsheet filled with names and addresses of adventurers eager to travel with her. However, there's a common issue. Mistakes often occur in the postal codes. Erica wants to simplify her task by using regular expressions or rejects to verify the accuracy of these postal codes. Each country has its own unique format for postal codes, which means Erica needs different rejects patterns for validation. By utilizing the Match Pattern Advanced module, she's able to map out these distinct patterns effectively. Additionally, Erica will use the switch module to toggle between different regex patterns within the same framework. This strategy allows her to identify incorrect postal codes easily and then notify Sally by email about any discrepancies that need attention. Let's dive in and assist Erica with setting up this practical scenario, ensuring her list of adventurers is accurate and ready for their journeys. In this scenario, we explore how to validate postal codes from different countries using regular expressions, or regex. This powerful tool allows us to ensure that the postal codes entered are correctly formatted according to specific regional patterns. We begin by utilizing the Match Pattern Advanced module, which efficiently maps the unique postal code formats for each country. To organize this data, a text aggregator is used. This module compiles the postal codes into a structured format, making it easy to share them via email. Think of it as gathering individual pieces into a coherent list, ready for communication. Connecting everything is the Google Sheets Search Rows module, which acts as the entry point for our data. By accessing a spreadsheet filled with contact information, all details flow seamlessly into the system without any filters. This broad approach ensures that no data is overlooked, setting the stage for accurate postal code validation. In this use case, we're focusing on validating postal codes from various countries using a combination of modules. Here, the switch module plays a crucial role. It examines the input data, specifically the country name, and matches it against a predefined list of possible values. Based on this match, it determines the appropriate regex pattern to use for validating each country's postal code. This setup is like a decision-making process that directs the flow of data by selecting specific rules based on the country identified. After the switch module has determined which regex to apply, we use a filter to ensure that only the rows with a successful match proceed. This happens when a valid country name is specified, allowing us to focus on data that's structured correctly. In essence, the switch module acts as a sophisticated traffic controller, directing each postal code query down the correct path for validation, while the filter ensures we only process accurate results. This method not only streamlines the validation process, but also sets the stage for efficient data handling and organization. In this scenario, we're exploring how to validate postal codes across different countries using advanced tools. First, let's talk about the Match Pattern module. This powerful tool checks whether a postal code matches the specific format required for a given country. It uses something called regex, short for regular expressions, to do this. Regex is a sequence of characters that define a search pattern, allowing you to find complex patterns within text data. For each country, a unique regex pattern is set. This is managed by the switch module, which determines the correct pattern based on the country name. If a postal code is valid according to this pattern, the match pattern module will create an output bundle, essentially a package of data signifying a successful match. But what happens if a postal code doesn't match? In that case, no output bundle is created. This is critical because we want to capture instances where postal codes are incorrect. By using a filter, we can identify these non-matching cases and focus on rows where no output bundle is generated. Finally, the information about incorrect postal codes can be gathered and processed further, making it easy to handle discrepancies and ensure data accuracy. This structured approach is not only efficient, but also allows for seamless validation and error management in various data sets. In this scenario, we're exploring how to effectively handle postal code validations using a combination of tools and techniques. First, we utilize regex to confirm that postal codes meet the format standards for various countries. This ensures that each postal code is not just a random string, but adheres to expected patterns for specific regions. Next, the Match Pattern module plays a crucial role in mapping these postal codes. This advanced feature tailors the validation process for different countries, accommodating their unique postal code formats. Once validations are complete, the text aggregator module steps in. This tool organizes the results, particularly focusing on those postal codes that fail validation. The key task here is to prepare the information for communication. Importantly, we aim to send out email alerts only when incorrect postal codes are detected. By incorporating a filter, we ensure that emails are triggered solely when there are validation failures. This approach not only streamlines communication, but also allows for timely manual intervention when necessary. By integrating these modules, we're able to create a smooth, efficient process that enhances data accuracy, and communication effectiveness. In this scenario, we explore the process of validating postal codes for various countries using regular expressions or regex. Regex is a powerful tool that helps ensure that each postal code meets the specific format required by different countries. We start by mapping these postal codes using an advanced match pattern module. This module allows us to efficiently handle the diverse formats encountered worldwide. Once the postal codes are validated, a text aggregator structures this information to prepare it for easy dissemination. The final step involves sending an email through Gmail. This email, directed to Erica, contains details about any postal codes that failed the validation. Erica's role is vital, as she reviews these incorrect entries and contacts the users directly to correct the information. This process enhances data accuracy and ensures communication is smooth and reliable. By validating postal codes before sending emails, we maintain data hygiene and improve customer interaction. In this scenario, we're diving into the process of validating postal codes using regex, a powerful tool for pattern matching. Imagine we have a data set containing various postal codes, and we need to ensure their accuracy for countries like Italy. To begin, the process starts with a search through the data. Using a switch, we identify the country associated with each postal code. Once the country is determined, we employ the match pattern module. This advanced feature checks if the postal code conforms to the specific format required for that country, in this case Italy. Any incorrect codes are filtered out and organized by the text aggregator. This tool compiles messages that are then sent via email, highlighting the errors. This email is crucial for flagging discrepancies, ensuring that the recipient can address any issues manually. Overall, this scenario showcases how automation can streamline data validation, providing a robust solution for maintaining data integrity. In this scenario, we're examining how to handle postal codes by integrating them with a Google Sheets database that holds contact details. By connecting to this spreadsheet, we ensure that all relevant data can be efficiently accessed and utilized. Since no specific filtering criteria are set, the system retrieves all entries within the spreadsheet. These entries are then seamlessly passed along for further processing. This approach is crucial as it establishes a comprehensive data pipeline, allowing subsequent modules to operate without missing any crucial information. Think of it as setting the stage for a series of actions that will refine and validate postal code data, ensuring accuracy across different countries. This setup is instrumental in automated data workflows, where the goal is to minimize manual errors and enhance efficiency. Let's explore how this system uses patterns to handle postal codes from different countries. Here we have a straightforward scenario using a switch module, which involves setting patterns to recognize country names and their respective postal code formats. For instance, if we're dealing with French postal codes, the pattern is set to recognize either France or the abbreviation FR. When a match is found, a specific regex pattern for French postal codes is produced. Similarly, the setup for Italy uses the terms Italy or IT, triggering the corresponding regex for Italian postal codes. The system is flexible, allowing for either full country names or their abbreviations, thanks to the pipe character in the regex, which acts as a logical OR. This setup ensures that the correct pattern is applied efficiently. If no match is found, the process doesn't produce an output, keeping the scenario streamlined. As an important point, Remember that the output here is a string representing the regex pattern, which will be crucial in the subsequent steps where we validate the input postal code specifically. In this part of the scenario, we'll examine how the system processes an Italian postal code. We're leveraging regular expressions or regex to validate postal codes across various countries. This process involves using the match pattern module to accurately map and verify postal codes for each country. Only bundles that successfully match a specific regex pattern advance through the system. This means that if a postal code is correctly formatted for Italy, the associated data continues through the process. Otherwise, it's filtered out, ensuring only valid information is used in subsequent steps. By using this approach, we maintain data accuracy and streamline operations, focusing only on information that meets the required criteria. In this section, we're diving deeper into how regular expressions, or regex, play a key role in validating postal codes for different countries. Let's focus on how this works for an Italian postcode. The match pattern advanced module allows us to use a string from the switch module as our regex pattern, which ensures we're using the right format for each specific country. When an Italian postcode is entered, the module checks whether it matches the predefined regex pattern. If the pattern matches, it confirms the postcode is valid and the module outputs a bundle, effectively passing through the data to the next step. However, if the postcode doesn't match the regex pattern, no bundle is outputted, indicating an invalid or incorrectly formatted postcode. This process helps maintain data integrity by automatically filtering out incorrect entries, ensuring only valid data proceeds. Understanding how regex validates against specific country formats is crucial for managing and processing data efficiently across different geographical regions. In this section, let's focus on identifying postal codes that don't meet the validation criteria. When a postal code fails the regex validation, it means there's no match, and as a result, no bundle of data is produced. This scenario allows us to capture information specifically from these incorrect entries. To effectively isolate these faulty rows, we'll employ a filter. This filter will sift through our bundles and highlight only those where no output is present. By doing so, we're able to target the discrepancies in the data, allowing us to address and correct these specific instances. This approach not only ensures data accuracy, but also enhances the overall efficiency of handling postal code records across different countries. In this example, we're focusing on how the system identifies incorrect postal codes using regular expressions or regex to validate entries from different countries. Here we have an Italian postcode example that fails the validation check. This specific entry is flagged as incorrect with a row number, showcasing an invalid postcode of 123 inches for Italy. To handle these discrepancies, we employ the text aggregator module. This tool gathers all the flagged entries that didn't pass the postal code check. By consolidating this information, it becomes easy to manage and review problematic entries. Once aggregated, this data can be efficiently shared via email, ensuring that stakeholders are informed of any issues needing attention. This automated process not only streamlines communication, but also helps maintain data quality across the system. In this use case, we're focusing on ensuring that emails are only sent when postal codes are incorrect. This involves a smart filtering process. After running postal codes through the regex validation, any incorrect entries are flagged. These entries are then passed through the text aggregator module, which compiles the problematic data. The key step here is using a filter to check if the output text bundle is not empty. If there's data in the bundle indicating errors, the filter allows the process to move forward, triggering the email alert. This method ensures that communication is streamlined and only necessary alerts are sent, keeping the process efficient and focused on incorrect entries. In this scenario, we're applying an example to validate postal codes using an Italian postcode. The process starts by leveraging regular expressions, or regex, a powerful tool that helps match patterns within text to ensure that each postal code fits the correct format for different countries. To manage this, the Match Pattern Advanced module is utilized, allowing us to map and check various postal codes effectively. If the regex does not validate a postal code, the entry is flagged as incorrect. The system captures this data and writes an email that outlines the lines with any discrepancies. This automated email provides a quick way to notify about incorrect postal codes, ensuring that any issues can be addressed promptly. This approach not only enhances accuracy in data entry, but also streamlines the communication process, saving time and reducing errors. Before diving into the process of building this use case, it's essential to set up your workspace with the right tools. And begin by heading over to Google Drive. Here you'll create a new spreadsheet specifically for organizing contact details. This will form a crucial part of our workflow. Name your spreadsheet, make advanced C04U04 to keep everything clear and organized. Next, you'll need to gather the contact information. Simply copy the data and paste it into your new spreadsheet. This step is straightforward but foundational, as it initializes your data set for further processing. Your completed spreadsheet should have a clean layout with columns for first names, last names, emails, and other contact specifics. This structured approach ensures that the information is easily accessible and ready for the next steps in our process. Once you have set this up, you'll be well prepared to move forward and begin building the use case. Now that you've set up your spreadsheet, it's time to dive into building the use case for postal codes. Begin by creating a fresh scenario and name it Make Advanced C04, use case 1 inch. This will help you keep everything organized as you proceed. First, add a Google Sheets Search Rows module. This module is essential for retrieving data from your spreadsheet. Connect this module to your Google account and select the spreadsheet you prepared earlier. Make sure you choose Sheet 1 as the sheet name and leave the other settings as they are before saving your configuration. Running this module will fetch all the rows in your spreadsheet and convert them into bundles. These bundles will be crucial as we continue, serving as inputs for subsequent modules in the process. Don't forget to execute the scenario. This activates the data retrieval, making it ready for the next steps where you'll map the items in the bundle. Now that we're diving into the heart of building our use case, let's explore how to utilize the switch module. This tool is pivotal for tailoring responses based on different countries' postal code formats. The main goal here is to harness this module to output the appropriate regex pattern for each country. Imagine you're setting up a system that might receive postal codes from around the globe. Each country has its own unique format which requires specific handling. This is where the power of the switch module comes into play. You'll configure it to detect the country from your data and then provide the corresponding regex pattern needed for that country's postal codes. It's crucial to go through each stage methodically. Each step builds on the last, ensuring that your final setup is robust and adaptable. So take your time with this module as it lays the groundwork for accurately processing international postal codes. Let's dive into setting up your module for managing postal codes. The first step involves mapping the country column from your Google Sheets module into the input field. This sets the foundation by specifying which country's data you want to work with. Next, enable the option to use regular expressions. By selecting Yes, you equip the system to match patterns more flexibly with the country's name, allowing for more precise data handling. Now, under the Cases section, define a unique pattern for each scenario. This involves specifying the pattern for the country names you want to identify and its corresponding output, which, in this case, is the regex pattern applicable for each country. The goal here is to have the country's name as your input and the regex, specific to that country, as your output. This setup will ensure your system dynamically handles postal codes across different nations. Don't forget to add each case by clicking on Add Item so you can manage multiple country-specific patterns. You're all set to move forward. To begin building this use case, you need to define patterns for postal codes using regular expressions for 4 countries: France, Italy, Japan, and the United Kingdom. For the French postal code, you can specify the country as either France or its abbreviation FR. By using a regular expression, you allow flexibility in matching either option. The vertical bar or pipe symbol vertical bar acts as an OR operator in these expressions. In the pattern field, you'll input France vertical bar FR. This setup captures both formats using a single line of code. For now, you'll leave the output field empty, as it will be specified later. Repeat this process for the remaining countries by adding more items under the Cases section, ensuring each country name is paired with its respective regex pattern. This step lays the foundation for handling various inputs efficiently. As we continue building our use case for postal codes, let's focus on incorporating country names using regular expressions. For Italy, you can use either Italy or its abbreviation IT. By adding both terms separated by a pipe symbol in the pattern field, you ensure the regex can match any version. Similarly, for Japan, you can specify either Japan or its abbreviation JP. Enter these options in the pattern field to catch both variations. Now, moving to the United Kingdom. It's slightly more complex due to its multiple accepted names. You have the options of England, UK, or EN. By using the regex pattern with all these terms, you enhance the flexibility and accuracy of your search. Remember, we'll address the output specifications for each of these countries in the next part of the exercise, so stay tuned to complete this setup effectively. When working with regular expressions, using tools like regex 101 can make your life much easier. This platform allows you to test and refine your regex patterns effectively. A key feature is the Copy button, which encapsulates your regex with delimiters and flags like global or multi-line. However, for our purposes, you typically only need the core expression. For example, if your regex is designed to match 2 digits, you're interested in just the part that looks like \D with curly braces. To streamline this process, avoid using the copy button if you don't need these additional characters. Instead, manually highlight and copy the portion of the regex you need. This ensures you have exactly what's necessary without extra formatting that can complicate things. Using this approach will save you time and prevent errors when implementing your regex in other applications. When building a regular expression for the French postcode, it's important to understand the typical format we're working with. In this case, we often see a pattern like F75008. The initial F signifies the country code for France, often used in international mailing. Following this prefix, we have 5 digits representing the specific location. A crucial detail here is flexibility. Sometimes the IFA prefix might be present, and other times it may not. In constructing our regular expression, we need to accommodate both possibilities. This ensures that our pattern can accurately match the postcode whether the prefix is included or not. As we start crafting the regex, think of it as a sequence built from smaller, manageable components. This approach lets us handle each part, like the optional prefix or the mandatory digits individually, making our final expression both precise and adaptable. Keep this breakdown in mind as you proceed with each step. To build a regular expression for a French postcode, you first need to understand the format. In international contexts, a French postcode might include an F followed by 5 digits like F75008. However, this prefix is typically used for international mail, while in France, postcodes are simply 5 digits. Let's focus on specifying the F part. Since it's a literal string, you'll use literals in your regex. It's crucial to note that F isn't always required. By recognizing the difference between international and local usage, you'll be ready to build a more flexible regex. In future steps, we'll look at how to handle the actual digits, ensuring your regular expression covers all possible formats. In constructing a regular expression for a French postcode, you want to account for an optional prefix of F. This is common in international contexts, but not always present domestically. To handle this variability, you'll use the question mark quantifier represented by the symbol. This quantifier signifies that the preceding element, in this case F, may appear 0 or 1 time. Begin by enclosing F in parentheses. This step groups the elements together, ensuring the question mark correctly applies to the whole prefix instead of just the hyphen. When you follow the brackets with a question mark, you're telling the regex engine to look for either no instance or a single instance of F. This approach keeps your expression flexible and suitable for both domestic and international formats. By mastering these small adjustments, you increase the adaptability and accuracy of your regular expressions in processing French postcodes. Let's continue building the regular expression for a French postcode. We've covered handling the optional F at the beginning. Now let's focus on specifying the sequence of digits that follows. A French postcode consists of 5 digits after the optional F. To express this in a regular expression, we use the \d, which represents any digit from 0 to 9. To ensure exactly 5 digits are matched, we follow D with the curly braces and the number 5 inside 5. So when we combine these elements, our expression looks like this, ED5. This tells the system to look for a sequence of exactly 5 digits, neatly capturing the essential format of the postcode. By structuring your regex in this way, you're ensuring flexibility for formats with or without the FO, while precisely defining the numeric component of French postcodes. Now that you've constructed the regular expression for the French postcode, let's ensure it's precise and complete. The French postcode can sometimes start with F followed by 5 digits. However, the F might not always appear. To account for this, we use the pattern F is 5. It's important that this value stands alone in the string, meaning there's nothing before or after it. This is where anchors come into play. The caret symbol circumflex ensures that the pattern starts right at the beginning of the string, while the $$ ensures it ends at the string's conclusion. By placing these anchors around your expression, you confirm that this exact pattern forms a single, standalone entry. Once you've encapsulated your expression like so, EFRD $5, you're set. This regex guarantees you'll match only the intended French postcode format. Go ahead and copy it into the output field for item 1. With this step complete, your regex for the French postcode is now ready for use. To build a regular expression for an Italian postcode, let's explore the format. An Italian postcode is made up of 5 digits, simple and straightforward. Think of each digit as a building block. Our goal is to use regular expressions, or regex, to accurately represent the structure. To specify any digit in regex, we use the pattern D, and since we need exactly 5 digits, we follow it with 5. This combination ensures we're capturing exactly 5 numerical characters, no more, no less. By doing this, we're defining a pattern that precisely matches the Italian postcode format. As you construct this regex step by step, consider how each component plays a role in validating the input. It's a powerful method to ensure that the data you're working with fits perfectly with the expected format. Keep this pattern in mind as you apply it to other postcodes or numerical sequences. To create a regular expression for an Italian postcode, let's start by looking at the example provided, 24041. Italian postcodes consist of exactly 5 digits. We'll represent any digit with the shorthand D, which is a common way to denote any digit from 0 to 9 in regex. Now, since we know we want exactly 5 digits, we'll use 5 to specify the precise number of times we want the digit to appear consecutively. So by combining these, you'll have D/5, representing any sequence of 5 digits, This pattern ensures that the input matches what we expect from an Italian postcode. Think of this as a simple yet powerful way to validate that any given input corresponds to the standard format for these codes. It's an efficient approach used not just for Italy, but can be adapted for various numeric patterns in data validation processes. When creating a regular expression for an Italian postcode, it's important to consider the structure. Italian postcodes consist of exactly 5 digits. To ensure accuracy in our pattern, we'll use regular expression anchors. Anchors like the caret symbol, circumflex, and the $sign play a crucial role. They help us define the boundaries of the pattern, indicating that it should start and end exactly with these 5 digits, without any extra characters on either side. In our expression, D represents any digit from 0 to 9. By adding 5, we specify that exactly 5 digits are necessary. The complete expression, D $5, effectively asserts that we're looking for a string that contains exactly and only 5 digits. This pattern ensures that each Italian postcode in the data we're working with will be properly validated against this structure. Once you've crafted your regex, you can simply copy it and use it where needed. This step maintains the integrity of your data input and ensures consistency. To construct a regular expression for a Japanese postal code, let's start with the example 1500043. Notice that the format consists of 3 digits, a dash, and 4 more digits. Begin by specifying the first part with 3 digits. In regular expressions, we use to represent a digit and 3 to indicate exactly 3 occurrences. Next, we add a literal dash, which is simply represented by the character. Finally, we specify the last 4 digits using D4. By combining these elements, you create an expression that matches the precise structure of Japanese postal codes. This step-by-step approach helps ensure that your pattern is accurate and reliable. To build a regular expression for a Japanese postal code, we start by focusing on the initial set of numbers. A typical postal code, like 1500043, begins with 3 digits. In regex, we use DD to represent any digit. To indicate that we require exactly 3 digits, we follow the SHD with curly braces containing the number 3, like this. D3. This syntax ensures we capture the pattern of 3 consecutive digits, forming the first part of the postal code effectively. Understanding this basic structure is key as we piece together the complete expression step by step. Let's continue building your regular expression for a Japanese postal code like 1500043. We've already specified the 3 initial digits using D3. Now it's time to include the dash that separates the 2 parts of the postcode. In this context, the dash is just a regular character, so you can add it directly without any special escape character. This is because it's not part of a character class or a wildcard. Understanding how to handle different characters in regular expressions is crucial for building precise patterns. Remember, handling special characters correctly ensures that your regex functions as expected. Now let's move on to the next part, where we'll define the 4 digits following the dash. To construct a regular expression for a Japanese postcode, it's important to break it down into its fundamental components. Consider the postcode 1500043. It comprises 3 parts: a sequence of 3 digits, followed by a dash, and then 4 more digits. In regex terms, we use the pattern D3 to match the first set of 3 digits. The dash is included as is, since it isn't a special character needing escape in this context. Finally, use D4 for the last segment. By combining these, you build an expression that accurately matches a Japanese postcode format. Now, let's incorporate these steps interactively to form our complete regex. To create a regular expression for a Japanese postcode like 1500043, you'll want to ensure that you cover each element of the postcode structure. This format involves starting with 3 digits, followed by a dash, and concluding with 4 digits. To capture the entire format within your rejects, you'll use anchors. Anchors are important because they specify that you are matching the entire string from beginning to end. The caret symbol or circumflex is used at the start to indicate the beginning of the string. The $ dollar is placed at the end, signifying the termination of the string. Your complete rejects should appear as caret symbol \d left curly bracket 3 right curly bracket dash \d left curly bracket 4 right curly bracket and $. Once you have your reject set, you can add it to the relevant output field. This ensures the format is correctly recognized within any program or script you're using. By carefully constructing this rejects, you'll ensure accurate validation of Japanese postcodes. Now let's dive into creating a regular expression for a UK postcode. UK postcodes have a distinct format such as SW1W0NY. The challenge here is to account for variations in letters and numbers. To begin, focus on the structure. Typically, it starts with 1 or 2 letters. Right after the letters, we usually find 1 or 2 numbers, which might even be followed by another letter. There's a space, then a digit, and finally 2 letters. Understanding each component's role helps in defining an accurate pattern. As we go through each step, we'll create a template that captures the diversity of UK postcodes. By breaking it down in this way, building your rejects becomes a logical step-by-step process that's both manageable and rewarding. Let's dive into creating the beginning of a regular expression for a UK postcode. The first step is to specify the initial part of the postcode, which consists of 1 or 2 capital letters. This represents the area code. In rejects, we use brackets with a range to match specific characters. Here, AZ is used to denote any uppercase letter from A to Z. By adding the quantifier 1, 2 after the brackets, we define that this pattern should match 1 or 2 uppercase letters. This helps us cover all possible permutations of UK postcode area codes efficiently. Visualizing it with the example SW1W0NY, SW represents that range. By defining these initial letters in our rejects, we're laying the groundwork to capture valid area codes across the UK. Now, let's focus on the next component of the UK postcode, defining the district element. This part of the postcode is crucial as it consists of numeric digits and potentially a capital letter. You'll often encounter 1 or 2 digits or an intriguing combination of a digit followed by a capital letter. The key is that a digit is always required here. Using the regular expression symbol for a digit, which is \d, you effectively scan for any numeral. Understanding this structure ensures that your regular expression can accurately capture this variety in UK postcodes. Let's delve deeper into building a regular expression for a UK postcode. In this step, we're focusing on what comes after the first mandatory digit. Here you have 3 possibilities. It could be a capital letter, another digit, or it might have nothing at all. To represent this variation, we use square brackets containing AZ for letters and ED for digits. This tells us that either a letter or a digit can follow. To account for scenarios where this character might be absent, we add a question mark after the brackets. Using signifies that the preceding character set, whether it's a letter, a digit, or neither, appears 0 or 1 time. This flexibility ensures our regular expression accurately reflects the diverse formats UK postcodes can take. Understanding each character and symbol in a regex is crucial for crafting robust patterns that match your exact needs. Keep these concepts in mind as we continue building our regex step by step. To continue building our regular expression for a UK postcode, let's focus on the next component, the space. In the context of a postcode like SW1W0NY, it's important to accurately represent the structure, and that includes spaces. In regular expressions, spaces are matched using the shorthand ESS. This tells the expression to look for any white space character like a space, tab, or line break. Including the space ensures our rejects can precisely match the format we're expecting, keeping it both accurate and reliable for different postcodes across the UK. Let's delve into building a regular expression for a UK postcode. We're focusing on the sector part of the postcode, which is represented by a single digit. In rejects, digits are captured using \D. This symbol is versatile, allowing us to specify any single digit from 0 to 9. In a UK postcode like SW1W0NY, the 0 represents the sector and you capture it by simply using D in your regular expression. This step-by-step approach helps ensure your rejects correctly matches the specific format of a postcode, creating a robust search pattern. Understanding and using D effectively is crucial as it forms the backbone of this part of the rejects pattern. To build a regular expression for a UK postcode, it's essential to understand its format. Let's break down the example SW1W0NY. The regular expression pattern AZ12DAZ DAZ2 efficiently captures this structure. It starts with one or two capital letters thanks to AZ12. This accounts for the potential variety in the outward code. Following the letters, we have a digit represented by LAD, which stands for any digit from 0 to 9. It may optionally be followed by another letter or digit captured by a Z. A space, denoted by AS, separates the two parts of the postcode. After the space, we have another digit followed by two uppercase letters captured by GDZ2. Here, AZ2 specifies that exactly two letters are required for the unit. By understanding these components, you can create a regex pattern to match various UK postcodes accurately, ensuring each character class and quantifier plays its role in validating this unique format. Let's explore how to complete your regular expression for a UK postcode. This process involves several steps to ensure accuracy. The example postcode we're using is SW1W0NY. To begin, establish the starting point of your expression with an anchor, represented by the caret symbol, circumflex. This ensures that your pattern matches right from the beginning of the string. Next, we specify that the postcode starts with one or two capital letters. This is done using AZ12. We then include a digit denoted by D. Postcodes can sometimes have an additional letter or digit captured with AZ. Next up, include a space characterized by S, as every UK postcode has this separation. Following the space, we use a single digit, represented again by D. Finally, two capital letters finish off the regular expression pattern, which we notate as AZ2. Conclude this pattern with a $sign, dollar, as the closing anchor, securing the pattern from the end. Now your full regular expression is ready to be used. It can be copied into any system that requires it and will effectively match UK postcodes following this specific format. Make sure you have inserted this complete regex into the relevant field to ensure your workflow is seamless. Let's dive into how we can set up our text parser for this postal code use case. First, it's important to configure the parser so it knows exactly what to look for. We'll ensure that global match, case sensitivity, multi-line, and single-line options are all set to no. By doing this, we simplify the search, making sure we only find the precise matches needed for our purpose. Next, let's make sure our process continues smoothly, even if no matches are found. By selecting Yes for continuing the execution, we allow the system to move forward without interruption, which is crucial for maintaining a seamless workflow. Focus on specifying the pattern using the output from your switch module. This pattern utilizes your regular expression to verify postal codes within Google Sheets. Make sure to enclose the pattern in brackets so that any matching strings are correctly captured. For your input text, we're looking at the country code column in your spreadsheet. You'll need to map the postal code field accordingly to ensure everything matches up correctly. Once everything is set, move forward by clicking OK. To ensure your postal code processing runs smoothly, let's set up a filter to manage how data moves through the modules. The goal here is to only allow data that has a valid output to pass through. If a country code isn't specified, there won't be any output to process further, so we need to stop it right there. First, connect your Tools module with the Text Parser module. In the filter menu that appears, look for the condition field. Here, you'll map the output from the switch module. This is crucial because it tells the system to check whether there's valid data to work with. Next, choose the basic operator called exists. This ensures that only the data bundles with actual output get sent on. By filtering in this way, you efficiently streamline data processing and minimize errors. Once you've done that, make sure to save this configuration. This small step is key to maintaining an organized and efficient workflow as you build this use case. Remember, taking these careful actions at each stage will help you manage your data more effectively and move forward confidently. To continue building our use case for handling postal codes, let's focus on leveraging the text aggregator module. This module plays a critical role when there's a mismatch with the postal code pattern. Essentially, it helps collate relevant data from Google Sheets to alert users about rows containing errors. First, within the source module, choose Google Sheets and select the option to search rows. Make sure to toggle the advanced settings to access more customization options. When setting the row separator, select Other and specify the HTML tag in the separator field. This ensures that each piece of information appears on a new line in the email, making it clear and organized. In the text field, it's important to detail the specific information you want to communicate regarding the erroneous rows. Include the row number, the country, and the incorrect postal code for clarity. Remember, using effectively structures your email content as it indicates where each line break should occur. By following these steps, you're ensuring that users receive concise, readable alerts that help them easily identify and address errors in postal codes. Keep working through each setup stage to maintain integrity in your data validation process. To ensure our process captures only postal codes that do not fit our specified pattern, we'll set up a filter using the Match Pattern feature. This tool checks each postal code against a regex pattern. If the postal code matches, an output is generated. If not, there is no output. First, we need to strategically place a filter to let through only those data bundles without an output, which indicates a mismatch with the pattern. This helps us focus solely on incorrect postal codes. You'll want to link the text parser module to the text aggregator module. Here, you'll configure the condition. Map the value field from the match pattern module and choose the Does Not Exist option from the Basic Operators dropdown. This setup ensures only unmatched postal codes proceed to the next stage, allowing us to address issues effectively. Finally, save your configuration and continue to refine each component, ensuring everything works seamlessly. Before proceeding, ensure your switch module configuration is saved to avoid losing any changes. Once that's done, you're ready to add a Gmail module to send notifications about lines in your table with incorrect postal codes. Start by connecting to your Google account. In the recipient section, add your own email address to receive the test email. For the subject line, use postal codes that need to be changed to make the purpose of the email clear. In the email content, you'll want to include the list of incorrect postcodes. Write something simple like, "Here is the list of postal codes that are incorrect." Then make sure to map the text from the text aggregator module so this information is automatically included. Don't forget to click OK to save your settings. To ensure our system sends emails only when there's incorrect data, we need to implement a filter. This filter will act as a checkpoint between the text aggregator and Gmail modules. By setting up this filter, we make sure emails are dispatched only if the text isn't empty. First, establish a link between the text aggregator and the Gmail modules. In the filter setup, map the text item from the text aggregator module into the condition field. This allows the system to evaluate whether the text contains necessary corrections. Choose the Not Equal To operator from the drop-down menu. Then map the field to identify any empty strings using the text functions. This configuration ensures emails are only sent if there are genuine discrepancies in postal codes. Once everything is set, confirm by clicking OK, and don't forget to save your progress. This step is crucial for streamlining your notification system efficiently. Now that you've set up your filter, it's time to test your postal code scenario. Imagine receiving an email that flags incorrect postal codes. In this example, two entries need attention. The first entry lists a postal code for Italy incorrectly marked as ES 123. The second entry shows a postal code 435313T that doesn't follow Italy's standard format. By running the scenario, you can check your email inbox to see if these errors are effectively caught. This step ensures your setup is correctly filtering and identifying errors, allowing for timely corrections. Once you confirm the results, you'll have successfully validated your use case. Feel confident knowing that accurate postal data supports better delivery outcomes and enhances data integrity across systems. Let's dive into the second use case, focused on car registration plates. In this scenario, we'll explore the challenge of managing and verifying vehicle registration data. This data is crucial for maintaining accurate records and ensuring compliance with legal standards. We'll discuss the problem of incorrect or outdated registration information, which can lead to various issues, including legal complications and inefficiencies in fleet management. Through this use case, you'll see how data validation and regular updates can streamline processes and improve accuracy. Finally, we'll outline solutions to address these challenges, such as implementing automated checks and data cleansing methods. These steps not only enhance the reliability of the database, but also support smooth operations within the organization. Erica the Explorer is embarking on a fascinating project involving car registration plates. She manages an agency that organizes ambitious exploration trips worldwide, and for this, she keeps a comprehensive database of driver details. This database is crucial for tracking everyone who facilitates these adventures. However, maintaining accurate records is vital, especially when dealing with essential information like contact details and car registrations. As we delve into this new use case, think about the significance of streamlined data management in ensuring the seamless operation of global explorations. Let's explore how Erica can overcome some of the challenges she faces in this endeavor. Now let's delve into Erica's second challenge, managing car registration plates. Erica received a document from Sally containing all the necessary registration numbers. However, Sally didn't format the document properly, resulting in a chaotic mix where no two lines look the same. For Erica, this disorganization creates uncertainty about potential errors in the car registration numbers. It's crucial for her to verify the accuracy of these records, especially since they are essential for her agency's operations. The next steps will focus on organizing this data, ensuring its correctness, and seamlessly integrating it into her existing database system. To tackle the challenge of managing car registration plates, Sally has structured the document more effectively. Each entry begins with the driver's email, ensuring that we can identify each driver uniquely. Following this, Sally has labeled the car registration number clearly with the prefix car registration equal sign. Erica's task is to extract these registration numbers accurately to update the database. This structured approach greatly aids in organizing the information. However, errors may still occur if a registration number is missing or incorrect. To address this, Erica will utilize the Match Pattern Advanced module. This tool will help in identifying and extracting the correct car registration numbers, ensuring that any inconsistencies are flagged with error messages. By implementing this system, Erica can streamline the process of maintaining accurate records, which is crucial for operational efficiency. Let's assist her in building this robust solution further. In this scenario, we are tackling the challenge of integrating car registration plates into a database efficiently. Currently, our database has essential information like drivers' emails, but crucial details like car registration plates are missing. This can impair database accuracy and functionality, making it vital to address this gap. To solve this, we extract the necessary data from a document where each entry begins with an email address. The data organization is somewhat inconsistent, yet there is an identifiable pattern where each car registration is preceded by the term car registration equals sign. Despite the disarray, we can leverage this pattern to systematically locate and retrieve each car registration plate. The objective is to enrich the database by accurately matching and extracting these car registration numbers using drivers' emails as identifiers. This process not only ensures data completeness, but also enhances the integrity and reliability of our system. By focusing on this methodical extraction and entry, we can significantly improve the utility and accuracy of the information we manage. Let's delve into how the email in the data store plays a crucial role in identifying information for car registration plates. Each email serves as a unique identifier, allowing us to locate the specific line in a document containing a driver's complete information. This includes their car registration details. When you have a messy set of data, using the email simplifies the process. It acts like a key, unlocking precise information by pinpointing the exact line where the driver's details reside. This technique ensures accuracy and efficiency, especially when handling large data sets with inconsistent formatting. By focusing on the email, we streamline data retrieval, making the task of updating or verifying car registration plates straightforward and reliable. In this use case, we focus on validating car registration plates based on country-specific formats using a system known as the switch module. This module helps in determining the correct format or pattern for each plate based on the driver's country information. For example, if the country is identified as the UK, the module outputs a regex pattern specifically tailored for UK registration plates. Similarly, if the country is Italy, it uses the Italian-specific regex. This ensures accurate validation aligned with regional specifications. In cases where the country doesn't match predefined options, a general regex is applied, providing a flexible catch-all solution. This approach not only maintains the accuracy of data, but also enables a smooth integration of international data into the system, ensuring each entry is validated appropriately. In this example, we're focusing on processing car registration plates. Each driver's information is extracted by identifying the string car registration equal sign within a specific line of a document. This string locates the car registration details, which the system then validates using a tailored regular expression or regex designed for specific countries. For instance, if the registration belongs to the UK, a unique regex pattern ensures the plate's format is correct. When the regex confirms the car registration is valid, it gets stored in the system's data repository. However, if the registration is invalid, a warning message is triggered, prompting further investigation. This approach streamlines validation, efficiently sorting correct registrations while flagging potential issues, ensuring the data's integrity is maintained throughout the process. In this scenario, we're going to streamline the process of handling car registration plates. We'll start by downloading the registration file from your Google Drive, which contains all the necessary data. We then extract the text data from this file to identify key information. Next, we'll retrieve data on drivers, followed by their specific information. This leads us to identify the car registration pattern, a crucial step for validating the registration plates. Once we have the car plate data, it's routed to determine if the information is correct. If everything checks out, the registration info is successfully added to the database. However, if there's an error, A warning will ensure that you're alerted to take corrective action. This process ensures a seamless and efficient handling of car registration data while minimizing errors. Let's dive into how we handle car registration plates in this scenario. We start by downloading a file from your Google Drive that contains the car registration data. This file might be a bit disorganized, so the first step is to clean it up and make it readable. Next, we extract the text data. This is where we convert potentially messy data into a structured format. From here, we move on to getting driver details. This involves searching records to find out who the registered drivers are and gathering specific information about them. Once we have the driver's info, we look for the car registration patterns. Identifying these patterns is crucial because it helps in validating the car plates accurately. We retrieve the necessary car plate details and use a router to determine the course of action based on the data's validity. Finally, we update the system with the new registration info and handle any discrepancies by triggering a warning for incorrect registrations. This ensures the entire process maintains integrity and accuracy. Keep in mind, as we progress, each step builds upon the previous one, creating a seamless workflow for handling car registrations effectively. When you download the car registration file from Google Drive, it initially comes in binary form. This format isn't directly readable, so the next step involves converting this data into text. To achieve this, you'll use the toString function, which translates the binary data into a text format that you can work with. Now, you also have the option to use the setVariable module to store this newly converted text data in a variable. This approach can make it easier to access and use the data later in your process. However, using the setVariable module isn't strictly necessary. You can also directly apply the toString function within the match pattern module if that suits your workflow better. Ultimately, the method you choose depends on your specific needs and the flow of your setup. In this part of the scenario, we're focusing on retrieving information from our data store. Here, the goal is to collect the contact details of all drivers. At this stage, we're not applying any specific filters, which means we'll be gathering a comprehensive list of driver information. This approach ensures that we have all the necessary data available for further processing steps, such as matching and pattern recognition, which you'll explore next. By starting broad, we avoid missing any crucial details and can fine-tune our selections as needed in later modules. In this module, we're focusing on how we can effectively use a driver's email to pinpoint their specific information within a messy document. Think of the email as a unique identifier that links each driver's data across different platforms. To achieve this, we'll be using a tool called regex, or regular expressions. Regex is a powerful method for pattern matching, which means it can search through text to find and isolate specific data based on a pattern, in this case, the email address. By doing this, we can align and verify information from both our data sources, ensuring accuracy and completeness. Once we've identified the correct data, we'll extract the specific line of text that contains the driver's details. This step is crucial for maintaining an organized and accessible database as we move forward in processing and analyzing the information. Using these techniques helps us efficiently manage complex data sets, ensuring that all driver information is precisely matched and retrievable whenever needed. In this part of the scenario, we're focusing on how the switch module functions to accommodate different country-specific rules for car registration plates. The switch module acts like a decision maker, allowing the workflow to change its pathway depending on the conditions set. Here, the key condition involves the country name found in the data store for each driver. By using this country name, the system selects the appropriate regular expression, or regex, which then evaluates the format of the car registration plate specific to that country. This method ensures that each plate is checked against the correct criteria, accounting for variations in registration formats across different regions. This way, we ensure accuracy and compliance with each country's regulations. This approach not only streamlines processing, but also enhances reliability, making sure the right procedure is applied every time. In this scenario, we're focusing on how car registration plates are verified for different countries. The match pattern module plays a key role here, acting as a tool to check if the car registration plate is valid for the specific country in question. Each country has its own format for registration plates, which is where regular expressions or rejects come into play. The switch module helps by providing the correct rejects for the country, ensuring that the format is accurately checked. Now, what happens when the registration plate is evaluated? If the plate matches the expected format, the module successfully outputs a bundle, which means the registration is correct. However, if there's no match, indicating an incorrect registration, the module doesn't produce any output. This efficient mechanism ensures that only valid records are processed further. In this scenario, we're streamlining the process of verifying car registration plates, ensuring accuracy and efficiency at each step. We begin by downloading a file that contains car registration data. This is followed by extracting the necessary text information from the file. Next, we search for driver details, allowing us to gather comprehensive information about each registered vehicle owner. Once we have this data, we proceed to examine the specific registration format required for each driver's country using advanced pattern matching techniques. This ensures that the car registration pattern aligns with the expected format, crucial for maintaining accurate data records. The car plate is then compared against these patterns. A key component here is the router, which plays an essential role in determining the outcome of each registration. If the registration format is correct, an output bundle is created, moving the data forward in the process. If incorrect, no output is generated, preventing inaccurate data from proceeding. This careful segregation facilitates smooth data management and helps maintain the integrity of the registration system. In this scenario of managing car registration plates, we focus on adding accurate information to our data store. After downloading the car registration files and extracting relevant data, we identify the drivers and gather their details. Next, we examine the registration patterns to ensure each car plate matches the expected criteria. A crucial step involves the router, which distinguishes between registrations that meet the criteria and those that don't. Here we apply a filter to ensure that only the correct registration numbers move forward. This process effectively updates the data store with verified information, maintaining the integrity and accuracy of our records. By filtering the results, errors are minimized, ensuring that only valid data is stored, which is essential for maintaining a reliable database. In this section, we're diving deeper into the process of managing car registration plates within the system. We begin by downloading the car registration file, which contains all the necessary raw data. This data is then extracted and formatted, allowing us to start identifying and sorting through the information. Next, we focus on matching this data with the appropriate drivers. Once we've pinpointed the correct individuals, we gather further details on each driver to ensure all information aligns accurately. We then move on to recognize the specific car registration patterns. This step is crucial for verifying the legitimacy of each plate. By extracting the car plate details, we can navigate through the data with greater precision. The router plays a pivotal role here, directing the flow of information to ensure both valid and invalid registrations are addressed. Valid registrations are added to the data store, while any discrepancies trigger a warning for registration errors. This warning system is essential. It flags incorrect plates, ensuring only accurate data is stored. By filtering out data that doesn't generate any bundles, we maintain the integrity and reliability of the registration information. This streamlined process ensures that any issues are quickly identified and resolved. Before diving into the scenario, it's essential to prepare by creating a text document containing the unstructured information we'll be working with. Start by using a basic text editor like Notepad. This choice ensures the data remains simple and free of additional formatting that can complicate later steps. Begin by copying the provided text and pasting it into your text document. Name the file mac04u04.txt to maintain consistent naming conventions. Once you've saved the document on your computer, upload it to your Google Drive for easy access. Remember, it's crucial to use a plain text document rather than a Google Doc. Google Docs tend to preserve formatting details such as fonts and headers, which can interfere with text data extraction and conversion processes. By sticking to a simple text format, you'll streamline the task of processing and extracting data later on. Let's dive into the use of regex for extracting car registration numbers from unstructured text. The data we're working with is quite disorganized and doesn't follow a standard format, which makes it challenging to identify specific details without advanced techniques. Imagine trying to sift through this jumble of information manually. It's nearly impossible to do efficiently. That's where regex, or regular expressions, comes in. Regex is a powerful tool used for searching and manipulating text by defining specific patterns to match. In our case, we'll use it to pinpoint and extract car registration numbers from the cluttered text. By the end of this exercise, you'll have a clear understanding of how regex can greatly simplify the process of handling messy data. This emphasizes the significance of keeping information well organized from the start, making future data processing tasks much smoother. Let's focus on preparing your data store for the car registration plates use case. Begin by adding a new data store named MAC04U04. This step is crucial because it acts as a dedicated space to store all relevant driver's information. Next, you'll need to choose a data structure. Think of a data structure as a framework that organizes your data, making it easier to manage and retrieve. Select an appropriate format that aligns with the types of data you plan to handle, such as names, emails, and car registration numbers. Set the data storage size to 1 MB initially. This size is adjustable, allowing you to increase it if your data needs expand in the future. Finally, ensure you create a clear structure that defines what kind of data your store will include. This organization helps streamline data processing and ensures you capture all necessary details efficiently. By setting these elements up correctly, you pave the way for a smooth and organized data management process. To prepare for setting up the car registration plate scenario, it's essential to ensure your data store is properly structured. Begin by adding a new data structure. This serves as the blueprint for how your data will be organized. Name this structure MAC04U04 to keep it consistent. Now let's specify the different types of information you'll store. Start by adding your first item. Under the name field, enter first name. Keep the data type as text. Add another item for last name, again leaving the default settings. Continue this process for other items like email, country, and importantly, car registration plate. Completing this setup accurately will enable you to manage records efficiently. Be sure to save the data structure and the data store to preserve your configuration. This careful preparation ensures all further steps in your scenario build go smoothly. Before diving into building your scenario for car registration plates, it's important to ensure your data store is properly set up. Start by selecting Browse and then click Add to input your data. You'll want to enter all the details such as first name, last name, email, and country. However, leave the key and the car registration plate fields empty for now. The key will be automatically generated and the scenario itself will fill in the car registration plate. Don't forget to click Save to make sure your entries are securely stored. Additionally, double check that the email addresses match exactly wherever they are used. This consistency is crucial for accurate data matching in your documents. Prepping thoroughly now will save you time and issues later. Now that you're setting the foundation for use case 2, it's time to dive into building your scenario. Start by creating a new scenario and giving it a straightforward name. This makes it easy to identify later on. You'll be using Google Drive to streamline the process of handling messy text documents. Begin by adding the Download a File module from Google Drive. If you're connecting to your Google account for the first time, don't worry. A pop-up will guide you to update your connection. Just click Continue and follow the steps. Once your connection is ready, it's time to specify the file you want to download. Using the Enter a File ID dropdown, select from the list. This helps you navigate to the exact document you need. Choose the file path to the document you previously created and save your module settings by clicking OK. Taking the time to complete each stage before moving on ensures a smooth setup for the next steps in building your scenario. In this part of building your scenario, we'll focus on converting the data from the downloaded file into a usable format. The document you downloaded is in binary form, which means we need to transform it into a string to work with it effectively. Let's start by adding the Set Variable module from the Tools menu. This step allows us to assign the converted string to a variable, which can be used later in the process. We'll name this variable car registration data to make its purpose clear. Next, use the toString function in the variable value section. This function is essential for converting the binary data into a text format. You'll need to map the data item from the Download a File module to ensure you're transforming the correct information. This step helps in changing the document's S format from binary to a readable string format. Once you've set everything up, remember to save your module by clicking OK. With these actions, you've successfully prepared the data for further steps in the scenario. To build the scenario effectively, the next step involves incorporating the data store into your process. Start by adding a data store. Search Records module. Select the data store labeled MAC04U04 that you've just prepared. This step is crucial because it ensures the information within this data store becomes accessible for the subsequent stages of your project. Once you've selected the correct data store from the drop-down menu, you can keep the remaining settings at their default values. Don't forget to click OK to save your choices. It's a good practice to keep your modules organized. Right-click on the module you just added and rename it to Get Contacts. This helps to clearly identify its purpose, especially when your scenario becomes more complex with multiple data stores scattered throughout. Without applying any filters, you'll have all the data in this store open and ready for use in the next steps. That means every piece of stored information is available, providing a complete data set for the use case you're developing. This comprehensive approach ensures no data is left out in the initial stages of building your scenario. In this step, we focus on using a text parser to effectively link document information with driver details in our data store. The key here is to utilize email addresses as a reliable identifier. Picture the email address as the starting point of each line, with additional relevant details trailing after it. You'll need to configure a text parser match pattern using an advanced setup. This involves setting various options to ensure the parser captures all necessary data. Set global match to yes if you want to find every possible match in the document, instead of stopping at the first match. Consider whether your search should be case sensitive. If precision is necessary, select yes to distinguish between upper and lowercase characters. With multiline, choosing yes means the parser recognizes the start and end of each line, crucial for documents where data spans multiple lines. Single line is about whether a dot matches new line characters. If set to yes, the entire text, including line breaks, is seen as a single string. Finally, decide if you want the route to continue even if there are no matches. Selecting no ensures that processing halts if no email is found. This guarantees that only complete data entries move forward. Once configured, the text parser outputs a bundle containing all details identified after the email, setting the stage for further data processing. In this part of the scenario, you'll be working with regular expressions to efficiently extract data. Begin by specifying the search pattern as a regular, mappable expression. Your goal here is to associate email information from your data store with the email present at the start of your text line. Place your email item from the data store into the pattern field. This step ensures the email is correctly mapped, creating a clear path for your data extraction process, marked by a colon for easy identification. To capture the remaining information on that line, you'll need to use parentheses in your pattern. Within these parentheses, use the expression asterisk. This signifies that any character can be captured, making the regex versatile and capable of handling various data types. Once your pattern is ready, move to the text field. Here, you'll map the car registration data that you've converted into a string. This is essential as it designates where the regex pattern will search. Confirm your setup by selecting OK, ensuring the configuration is saved and ready for the next steps. By following these instructions, you're well prepared to parse information smoothly and accurately. Now that we're diving into building our scenario, let's focus on organizing our modules effectively. Start by right-clicking the text parser module and renaming it to getDriver.info. This step helps distinguish it from other parsers you might have. Next, it's time to define regular expressions or regex for car registration plates specific to different countries. These patterns will enable the system to recognize and process the registration plates accurately based on regional formats. To manage this, introduce a tool switch module into your workflow. In this module, you'll map the country item from the data store module to the input field. This mapping is crucial as it helps the system determine which country's format to apply by checking against the specified patterns. Remember to select No for using regular expressions to match. This setting ensures that we'll handle the inputs as straightforward strings, keeping the matching process simple and clear. By setting these foundational elements, you're establishing a streamlined process for handling diverse car registration formats efficiently. Let's keep moving and make sure everything aligns perfectly. In this step, we're diving into the details of specifying cases for your car registration scenario. Think of each case as a unique condition or rule you're setting up for different countries. This involves defining a pattern that aligns with the country name in your data store. Imagine the pattern as a specific identifier. When a piece of data, like a country name, matches this pattern, the switch module knows which registration plate format to apply. It's like setting up a personalized response system for each country you'll deal with. To get this rolling, you'll start by adding a case for each country you want the system to recognize. Clicking the Add Item button allows you to create a new case. You'll need to add 4 cases here, one for each of the specified countries: United Kingdom, India, Australia, and Italy. In these cases, pay attention to the entries in the pattern fields. Typing the country names precisely as listed, without extra spaces, is crucial for ensuring your system identifies and processes them correctly. In the next phase, you'll focus on defining the output for each of these cases. This means assigning the correct registration plate format that should be applied when a pattern matches. With this step, you're building a foundation for a responsive and efficient system. Let's dive into the structure of a UK car registration plate. These plates follow a specific pattern. They begin with 2 letters that denote the region where the car was registered. Following those letters, you will find 2 numbers, which often indicate the age of the vehicle. Next, there's a space, and finally, the sequence ends with three more letters, which are randomly assigned. Consider this example, AB24CDE. This combination adheres to the format with the two initial letters AB, followed by the numbers 24, a space, and then CDE. Now, our task is to translate this structure into a regular expression, or regex, which is a powerful tool used to identify patterns in text. You'll be doing this step by step, ensuring a clear understanding of each component. In the next steps, you'll learn how to specify the components using regex syntax, starting with those two letters. This foundational understanding will be crucial as you apply similar logic to other car plate formats. To construct a regular expression for a UK car registration plate, let's start by breaking down its components. The pattern begins with two letters. These are represented using the expression AZ, which matches any uppercase letter from A to Z. To specify exactly two letters, we apply a quantifier, which in this case is 2. This tells the regular expression engine to expect two occurrences of the character class preceding it. Keep in mind this first step is foundational. Understanding how to specify letter sequences with AZ2 will be useful as we continue to develop our regular expression for the entire plate. Building this pattern step by step ensures accuracy and precision in capturing the structure of UK car plates. Let's explore the next steps of the pattern as we move forward. Now let's look at the next component of a UK car registration plate. We've already defined the first part using two letters. Now we need to represent the two numbers that follow. In regular expressions, numbers are matched using the backslash followed by a lowercase d. This symbolizes any digit from 0 to 9. Since we want exactly two digits here, we use the quantifier with curly brackets and the number 2. So the pattern we need is backslash d followed by curly brackets and 2. This structure ensures that our expression accurately captures exactly two digits in sequence. As we continue, these building blocks will combine to form a complete and effective pattern. When crafting a regular expression to match UK car registration plates, it's essential to break down each component. We've covered the initial sequence of two letters and two numbers. Now let's look at the space that typically follows. In regular expressions, spaces can be specified using the special characters. This character denotes any white space, not just a space, and is crucial for matching the format correctly. However, in some cases, a space might not be present. To account for this variability, you'll append a question mark after days. This indicates that the space is optional. It can appear once or not at all. By incorporating this into your regex, you maintain flexibility, ensuring accurate matches across various plate formats. Next, we'll address how to specify the final sequence of three letters using a similar approach. Keep these principles in mind as you build a robust, efficient regex pattern. To wrap up the process of constructing a UK car registration plate pattern using regular expressions, let's focus on the final component, the last three letters. Just like the starting letters, these can be any three uppercase letters. In regex, we represent this with the pattern AZ3, where AZ matches any capital letter and 3 specifies exactly 3 occurrences. Now, with all parts combined, your complete regex becomes AZ2, 2s, AZ3. Here's a quick breakdown. AZ2 captures the initial two letters, 2 matches the two digits, accounts for the optional space, and AZ3 captures the final three letters. Once your regex is structured, make sure to add it to the output field to test its functionality. This complete expression now seamlessly identifies the UK car plate format, providing a robust tool for validation when processing vehicle data. Let's dive into creating a regex pattern for Indian car license plates. An example of a typical Indian plate might look like this, KA03HA1985. It consists of several distinct parts. First, you'll notice it starts with two capital letters. These represent the regional code. Following that are two numeric digits, which often indicate the district within the region. After a space, there are two more capital letters. Finally, there's a sequence of numbers which can range from 1 to 4 digits, representing the vehicle's unique registration number. Understanding these components helps us build the rejects step by step, ensuring each part of the license plate is accurately captured. Start with recognizing the regional letters, continue with the numeric district code, capture the second set of letters, and end with the registration number. This structured approach will make your rejects both precise and robust. Let's dive into understanding the structure of Indian car registration plates and how to express them using regular expressions or rejects. The first component of an Indian plate consists of two capital letters. These letters represent the state or union territory where the vehicle is registered. For instance, KA stands for Karnataka. To capture this in rejects, we use the pattern AZ2. This pattern matches any letter from A to Z, and the 2 specifies that exactly 2 letters are needed. It's similar to the approach used in constructing rejects for UK plates. Understanding these components helps in accurately parsing or validating Indian car registration numbers in various applications. To build a rejects pattern for Indian car plates, let's continue focusing on the sequence after the initial letters. Following the 2 capital letters, Indian plates feature 2 digits. We specify digits in rejects using the \D symbol written as \D. This symbolizes any digit from 0 to 9. The quantifier in curly braces 2 ensures that our pattern expects exactly 2 digits. So together \D with the quantifier 2 will accurately match the 2-digit sequence found in this part of the license plate. This systematic approach helps ensure the rejects correctly identifies and processes Indian vehicle registration numbers. Let's dive into how we can construct a regular expression for Indian car license plates. When building a rejects pattern, we break down components to match the specific format. In the example provided, KA03HA1985, we see 2 uppercase letters followed by 2 digits, a space, and then more characters. First, we handle the letters with AZ2. Here, AZ captures any uppercase letter and 2 specifies exactly 2 of them. Next, for the 2 digits, we use D2. The D is a shorthand to match any digit, and 2 indicates we need 2 digits. There's a possibility of a space in the plate, which is optional. For this, we use S. This matches any white space character like spaces or tabs, and the E signifies that the space can appear 0 or 1 time. This step-by-step breakdown helps ensure we capture each part of the license plate format accurately. This structured approach makes rejects both powerful and flexible for pattern matching. Now that we've identified the initial components of an Indian car plate, let's focus on what's next. After the white space, we're targeting the letters that follow. On an Indian license plate, this section can have 1 or 2 letters. To capture this in our rejects, we use the pattern AZE, which tells us that we're looking for uppercase English letters. But to specify quantity, we employ the curly braces 1, 2. This indicates that the rejects should match either 1 or 2 letters after the space. By combining these elements, we're able to match the variable nature of this component of the license plate efficiently. This step is crucial for ensuring that we accurately recognize plates with varying letter counts. Keep this structure in mind as we continue to build our rejects pattern. Let's delve into constructing a regular expression for Indian car license plates. In this example, we have KA03HA1985. We'll break it down step by step. The sequence begins with 2 letters representing the regional code. To capture this, you'll use the pattern AZ2, which specifies any 2 uppercase letters. Next, we have 2 digits. The pattern for this is D2, indicating exactly 2 digits. You might notice a space after these digits, which is optional in some license plates. To represent this, include SS with the question mark indicating that the space is optional. Then we encounter another group of letters. Here it can be either one or two letters, so we'll write AZ12. This is followed by another optional space, which we again denote with X. Finally, the sequence ends with numbers. Depending on the plate, there can be 1 to 4 digits. The pattern for capturing these numbers is DNAR14. By piecing all these components together, we craft the regex pattern to match any standard Indian vehicle license plate format accurately. This modular approach ensures flexibility and precision in recognizing varying plate styles commonly seen across different regions in India. Let's dive into how you can create a regex pattern for Indian car plates. The example we've been working with is KA03HA1985. Each segment of the plate has specific requirements. First, you see the two letters KA, which signify the state code. You'll need two uppercase letters to capture this part. Next, there's the 03 representing a district code. For this, 2 digits are required. The pattern continues with an optional space, which you can represent in regex with a question mark following a space character. Following the space, the next part, hey, involves another set of characters, which could be 1 or 2 letters. To bring it all together, let's talk about the final section, 1985. Here you have between 1 and 4 digits to specify. This is where you'll use DIT to denote a digit, combined with the quantifier or 1-4 to indicate that the number of digits can vary from 1 to 4. Once you've constructed the full pattern, you can test it by entering the regex into the designated field. This will help ensure that it accurately matches the format of Indian car plates. Now that we've explored how to build a regex pattern for Indian car plates, let's turn our attention to Australian registration plates. An example format is shown as 18AA000. To create a regex for this, consider the structure. It starts with a single digit, followed by 3 uppercase letters, a hyphen, and then 3 digits. Each component plays a critical role in representing the plate accurately. Begin by specifying the initial digit using D. This will cover numbers 0 through 9. Next, for the 3-letter sequence, use AZ3 to ensure the letters are capitalized and you have exactly 3 of them. The hyphen is straightforward. You'll include that directly in your pattern as finally capture the series of 3 digits with D/3. By understanding each part, you can build a regex that mirrors this format accurately and can be applied consistently across various Australian plates. As you click through each step, remember that the careful combination of characters ensures your regex works flawlessly. Let's dive into the structure of an Australian car registration plate. They often start with a digit, followed by a specific sequence of letters and numbers. The first character, as you can see, is always a digit. In programming, particularly when using regular expressions, we represent any digit with the symbol \D. This is a convenient way to match any number from 0 to 9, covering all possible digits that might appear in this spot. As we walk through each part of the license plate format, you'll see how regular expressions can powerfully match these types of patterns. Let's continue our exploration of Australian car license plates by building the sequence step by step. Following the initial digit, we have a series of 3 capital letters. To represent these letters in a pattern, we use a bracket expression, AZ. This range specifies any uppercase letter from A to Z. Since we need exactly 3 letters, we add 3 directly after the bracket. This notation ensures that our pattern includes precisely 3 capital letters, maintaining the format of the typical Australian car plate. By understanding and applying these elements, we can construct a regular expression that authentically matches this part of the license plate structure. Let's explore how to construct an Australian car plate using regular expressions, an efficient way to match specific patterns in text. The registration plate format, like 18A000, starts with a single digit followed by 3 uppercase letters. In regular expressions, this initial segment can be represented as DAZ3. Next, we consider any optional space after these letters. In regex, a space can be indicated using HS, which is shorthand for a white space character. To specify that the space is optional, we use a question mark right after HS. This tells the regex to match 0 or 1 space character. By understanding these elements, we can build a true-to-format representation for Australian car plates, ensuring accuracy and flexibility in parsing text data. Now that we're diving into the structure of Australian car registration plates, let's focus on how they are formatted. Typically, these plates follow a pattern that combines numbers and letters separated by a dash. The format begins with a single digit followed by 3 uppercase letters, then a dash, and ends with 3 more digits. The dash in the middle plays an important role. It's unique because it doesn't require escaping in our regular expression. This means you can include it directly in the pattern. When dealing with characters like the dash, our regular expressions remain straightforward and clear. Constructing regular expressions can often feel like solving a puzzle, breaking down each segment to understand its role. By identifying these components, digits, letters, and special characters, we build a pattern that effectively represents the structure of these plates. Let's continue assembling our pattern step by step, ensuring a comprehensive grasp of each element involved. Let's delve into how Australian car registration plates are structured and how you can create a regex pattern to match them. The typical format consists of a single digit, followed by 3 letters, a dash, and 3 more digits. So, for example, a plate might look like one AA000. Now, let's break it down step by step. First, we start with a digit. In regex, a digit is represented by the symbol D. Next, we have 3 letters. In regex, a range of uppercase letters from A to Z is represented by AZ. Since there are 3 letters, we use a quantifier and 3 to specify this. Following the letters, there might be a dash. Interestingly, the dash might be accompanied by a space, although not always. In regex, a space can be represented as S, and if it's optional, we add a question mark to make it so S. This flexible structure ensures that any Australian car registration plate can be successfully matched using the regex you construct. As you click through each step, you'll see how this pattern comes together seamlessly. Let's dive into crafting a regex pattern for Australian car plates, which have a specific format, 1 digit followed by 3 uppercase letters, a dash or space, and ending with 3 digits. First, we start with the digit. Represent this with a backslash followed by a lowercase d. Next, you'll have a series of 3 uppercase letters. For this, use square brackets with uppercase A to Z, followed by a curly brace containing the number 3. This indicates repetition. After the letters, you may include a dash followed optionally by a space. In regex, this is represented by a dash and a backslash S with a question mark, signaling the space is optional. Finally, 3 digits complete the format. Again, use backslash D followed by curly braces with a 3 inside. Once your regex is complete, you can copy it and check it against samples to ensure it works correctly. This will help you understand and match the unique Australian vehicle registration pattern. Now let's dive into creating a regex pattern for Italian car registration plates. As you can see, a typical Italian plate looks like this: 2 letters, 3 numbers, followed by another 2 letters. To begin crafting our regex, we start with the 2 letters. For this, we'll use the pattern AZ2, which specifies any 2 uppercase letters from A to Z. Next, we need to capture the 3-digit number in the middle. We'll use D and 3 to represent any 3 numerical digits. Finally, the pattern completes with another pair of letters similar to the start. By putting this together, you'll effectively match the Italian car registration format. Stay engaged and feel free to ask any questions as you go through each step. To create a regex pattern for Italian car registrations, let's start by focusing on the sequence of characters involved. The format begins with 2 capital letters like CT in our example. To capture this in regex, you use square brackets AZ to represent any capital letter from A to Z. Since you need exactly two letters, you follow it with 2. This tells the pattern to match precisely two occurrences of whatever precedes it, in this case, two capital letters. This is how you ensure your regex is perfectly tailored to the Italian car registration format. Now let's explore how to construct the regular expression for Italian car registrations. In Italy, these registrations begin with two letters. Using the expression AZ2 allows us to specify that there are exactly two capital letters. Often these letters are followed by a space. In regular expressions, the special character S represents a white space. To allow for flexibility where the space might not always be present, we use the question mark. This indicates that the space is optional. There can be 0 or 1 space after the letters. By combining these elements, you're creating a flexible pattern that matches the typical structure of Italian car registrations effectively. This thoughtful construction ensures your regex can adapt to variations in spacing while accurately capturing the essential format. Now that we've started constructing the regex for Italian car registrations, let's continue by specifying the 3-digit sequence. In Italy, after the initial letters, you will see 3 numbers. To capture this pattern, we use the regex notation for digits. The digit symbol is represented by a backslash followed by a lowercase d. To specify that we need exactly 3 digits in a row, we follow the digit symbol with curly braces containing the number 3. So it looks like this: \d followed by curly braces containing the number 3. This part of the regex ensures that any 3-digit sequence is matched correctly, aligning with the standard format of Italian car plates. This method uses concise and clear regex notation for matching specific patterns in text, making it easier to parse and verify large data sets accurately. Let's continue building step by step, ensuring each part of the registration number is included correctly. Now that we're focusing on crafting a regex pattern for Italian car registrations, let's break it down. Italian plates follow a format like CT123DT. Starting with the letters CT and ending with DT, these are sequences of 2 uppercase letters. You'll need to specify this in your regex as AZ-2. This part of the pattern captures the letters, and using a 2 ensures there are exactly 2 characters. Next, there's a space before and after the numbers, which isn't always present. To account for this possibility, use the expression S. This will match a space if it exists, or none at all, due to the question mark symbol. Between these spaces, you'll have a 3-digit number captured using D3. The EAT ensures it matches digits, and 3 specifies there should be exactly 3 of them. By recognizing this pattern, letters, optional space, digits, another optional space, and ending with more letters, you'll be ready to match typical Italian license plates efficiently. In this segment, we're focusing on constructing a regex pattern for Italian car registrations, which typically follow the format of 2 letters, a space, 3 digits, another space, and 2 more letters like CT123DT. To start, we specify the initial 2 letters with AZ2. This signifies any 2 uppercase letters. Next, a space might be present, so we include S, allowing for optional spacing. Then for the numbers, we use D3, indicating 3 consecutive digits. Again, we consider potential spacing with another ERTS. Lastly, we capture the final 2 letters with the AZ2. Once your pattern matches the structure, you can copy it and paste it into the designated output field. This method ensures you're accurately filtering and identifying Italian car registration plates in your dataset. In this step, we're addressing scenarios where a car's registration pattern doesn't match any of our predefined cases. To handle these instances, we utilize the else field in our switch module. Here you'll specify an output pattern for cases that don't match, essentially capturing any data that doesn't fit the known templates. This is useful when dealing with registration plates from various countries where patterns might vary. We use the regular expression pattern circumflex plus in the else field. This pattern captures any number of characters that are not a semicolon. It's like telling the system, grab everything until you hit a semicolon. For instance, if you have a text that reads car underscore registration equal sign, this pattern will extract everything after the equal sign, stopping at the first semicolon or the line's end. This way, even if the format is unfamiliar, you still collect relevant information. Remember to save these settings in the switch module to ensure the process flows smoothly. To continue streamlining the process of extracting car registration plates from your documents, we're now going to focus on handling any potential errors smoothly. Begin by ensuring that you leave all flags unchanged and, importantly, set the option to continue the process even if no matches are found. This step is crucial because it allows your workflow to function seamlessly even when there are discrepancies in your regex pattern. By selecting yes, you're making sure that any unmatched cases are flagged as errors instead of halting the entire operation. This approach prevents loss of information and aids in identifying and resolving issues with specific entries. Next, incorporate a text parser, Match Pattern Advanced module. This tool will help in systematically analyzing and matching patterns in the text, ensuring the registration data is accurately captured every time. By preparing for such contingencies, you maintain continuity and reliability within your system, optimizing for accurate data retrieval and minimizing disruptions. In this part of the car registration plates use case, we're focusing on utilizing regex patterns to efficiently extract and validate car registration numbers. The output from the initial module provides a text line with all necessary driver information. This line includes the critical string car registration equal sign, which serves as a consistent marker in the dataset. By including this string as a fixed part of your regex pattern, you can reliably identify car registration details across different entries. This process involves specifying a consistent pattern in the pattern field, always beginning with car registration equal sign. To capture the specific car registration number that follows, you'll use brackets around the pattern. These brackets essentially tell the system to grab whatever fits your criteria following our fixed string. This is complemented by the switch module, where you'll map the country-specific regex solutions, ensuring the system recognizes and verifies the plate format based on geographic standards. This method not only facilitates accurate data capture, but also enhances the robustness of the data validation process, catering to different regional inputs seamlessly. To continue developing our use case for car registration plates, we'll focus on effectively mapping and processing the data. Consider this. The pattern you've built is a robust and mappable regular expression designed to identify and extract car registration details from text. Once you've set this pattern, it's important to confirm its accuracy by mapping the output correctly. Ensure you are choosing the right line of text from the initial module that gathers the driver des information. After configuring the module, confirm by clicking OK, and then rename it to Get Car Plate for better clarity later on. This naming helps distinguish between various parsing modules, facilitating easier navigation. It's crucial to map the information from the first match pattern advanced module. This module contains the original text line, ensuring accurate data processing. Remember, if a correct match is found, this module will produce a bundle, effectively validating your data extraction. If not, no bundle is generated. This process sets the stage for seamless data handling and prepares us for further analysis and actions based on the registration data we retrieve. Now, let's enhance our process by introducing a router. The router will help manage the flow of your data by creating two distinct branches. This setup allows you to handle different scenarios based on whether the car registration plate information is accurate or not. In the first scenario, if the car registration plate is correct, a bundle is generated. This bundle will then be processed to update the data store with the car registration number. This ensures that all valid entries are captured and recorded efficiently. In the alternative scenario, if the car registration is incorrect and thus no bundle is generated, you will send out a warning indicating that the number is not correct. This key step helps maintain data integrity by identifying and flagging inconsistencies. By setting up these distinct pathways, you can ensure efficient data flow management, reducing errors, and enhancing the system's reliability. Let's take a closer look at how to update a record within our car registration plate use case. Here, we'll focus on configuring a data store to ensure the correct information is stored efficiently. First, add an Update a Record module to the upper root. This allows us to select our specific data store. Here it's the MAC04U04 data store. This choice ties back to our previous setup and is crucial in maintaining consistency across the process. In the key field, you'll map the key item from the preceding data process, specifically from the Get Contacts module. This key acts like an identifier, pointing the module to the exact record that needs updating. It ensures that any modifications we make are applied to the correct data entry. Next, move on to the Records section. Here you'll map the value obtained from the Match Pattern Get Car Plate module. This step updates the car registration plate field in your data store. The precision in this process helps maintain data integrity and ensures accurate tracking of registration plate information. Once you've configured everything correctly, remember to save your module setup to implement these changes. These steps are vital in maintaining an accurate and efficient system for managing car registration data. To ensure we update only records with a correct registration plate, we'll set up a filter on the route from the router to the data store. We'll label this route as found and correct. This indicates that it serves as a backup or fallback route used only when data doesn't pass through any other routes. In the condition field, we're mapping the value from the Get Car Plate module. We then choose the text operator not equal to and map it to an empty string. By doing this, the system will only proceed with data that has a non-empty value, ensuring that only valid registration plates are processed. Once set, click OK to save the filter. This setup means only records with confirmed, correct registration plates will be further updated, enhancing data accuracy in the workflow. In this part of configuring the car registration use case, we're focusing on handling records that don't match the expected patterns. Here, you'll be using an Update a Record module to modify records in the MAC04U04 data store. The goal is to ensure that any incorrect or missing information is flagged appropriately. First, map the key from the initial data store. This acts as a unique identifier to specify which record needs updating. You'll want to set Insert Missing Record to No, ensuring you're only updating existing entries. Next, in the car registration plate field, you'll enter a warning message, incorrect or empty. This message will serve as a clear indicator that the data associated with this record is either incorrect or not present. After that, map the value from the Match Pattern Advanced Get Driver's Info module. This step helps identify the lines where information is missing or incorrect. It's important to note that the Match Pattern Advanced Get Car Plate output can't be mapped in this situation because there's no match, resulting in an empty output. Once you've configured these settings, remember to save your changes to apply the updates successfully. This ensures that any discrepancies are clearly marked and can be addressed promptly. To ensure that we effectively identify cases where car registration plates are incorrect or missing, we're setting up a filter labeled Incorrect or Empty. This filter functions as a fallback route, meaning it acts as a safety net for data that doesn't meet the criteria of the main processing routes. Imagine a scenario where data flows through various stages, but some of it doesn't match the expected patterns. In this case, when the registration plate data isn't validated or is absent. By marking this route as a fallback, we capture all such instances. allowing us to address these errors specifically. This setup helps prevent data loss and ensures that no significant information is overlooked, even if it doesn't conform to the expected format. After setting the filter, remember to save your configuration. This step solidifies the changes and prepares the scenario for testing. This approach reinforces the importance of error handling and helps maintain data integrity throughout the process. Great work setting up your use case scenario. Now it's time to test what you've built. By clicking Run Once, you'll trigger the process and see how it performs. Check your data store afterwards. This is where you'll find all the data collected, including any warnings for missing or incorrect registration plates. You've accomplished a lot in this session. You explored the text parser modules within Make and learned to leverage them for mapping parts or even all of your regex expressions. Recognizing the importance of a well-formatted document was crucial, helping you effectively assist Erica in gathering driver details. This effort ensures Archie has everything he needs for his upcoming journey to Make Dorado. Well done on achieving these milestones and advancing your skills in data handling and processing. Keep up the great work. Congratulations on completing this unit of the text parser course. We've explored some advanced features that are essential for effective data handling. First, you learned about the Match Pattern Advanced module. It's crucial for identifying specific patterns in your data, making it easier to extract and utilize the information you need. Next, we discussed mapping parts or all of your rejects within this module, allowing for greater flexibility and pattern recognition. We then covered the use of regular expressions in the switch module. This enables you to define both the pattern you want to detect and how you want to present the output, streamlining the entire data parsing process. Finally, we explored how to apply filters to tailor the output to meet specific requirements of your scenarios. Each of these tools contributes to a more refined and efficient data parsing strategy. Now, take a moment to reflect on what you've learned and get ready to apply these skills in practical tasks. Keep practicing, and you'll soon master them.